Okay, so good morning or good afternoon. Thank you for having me. My name is Emmanuel Smith, and I am a Senior Application Specialist for JEOL USA, and I mainly support cryoARM at JEOL. So that includes the cryoARMs, which are our flagship cryoARM instruments. Now, I do a lot of work with SerialEM, and in JEOL, we have a lot of experience with SerialEM, and we heavily support SerialEM. So the topic today will be on SerialEM MultiGrid, which is a relatively new feature that's quickly getting wide adoption across our cryoARM user base. Now, I'll talk some of its basics, but mainly I'm going to show you how to do a data collection. So hopefully by the end of this talk, you'll be able to go upgrade your SerialEM and start doing multi-sample data collection with SerialEM. Now, just to review SerialEM, it is, of course, an open source software for automated TEM control and data collection. Controls microscope, camera, stage, and autoloader. Scales from simple processes, manual operation, all the way to fully unattended data collection that could span days to several weeks if needed. You can do all sorts of experiments with it, single particle tomography, micro-AD, STEM, and montaging. Now, SerialEM also includes an extensive library of scripts that enables further customization and automation. And it's developed and supported by David Mastronardi at UC Boulder. And here is the website for SerialEM. Let me also turn on my pointer. Okay. And it's actively used and supported by the global TEM community. Now, at JEOL, SerialEM is integrated with the JEOL transmission electron microscopes. It's compatible with all cameras, and we support it through JEOL applications, but you can also get support through Nexperian, which is a company that provides SerialEM support. We include proven workflows for single particle and tomography, and we also provide SerialEM scripts and best practice templates. Now, these come with a fast setup, minimal installation cost, and long-term JEOL support. All right, so SerialEM MultiGrid. It's a fully integrated multi-sample workflow for high-throughput multi-day cryo-EM data collection. This streamlines the setup for data collection. Before MultiGrid, it took a lot of steps to set up routine data collection, but all those have been consolidated and automated in one single interface. It's fully integrated with the autoloader. And there's a single interface that manages inventory, mapping, and the data collection. Okay, so we are running MultiGrid on our JEOL cryoARMs, which are our dedicated cryo-EM instruments. I just want to show you some of its features that we take advantage of during MultiGrid. Now, the cryoARMs, we have one at 200 kV and one at 300 kV, and they have an autoloader that's called the cryospec porter. The autoloader includes a long-term storage cassette that's in the microscope and does not leave the microscope and can accommodate up to 12 samples. Instead, for transfer in and out of the microscope, we use a transfer shuttle that can exchange up to 4 samples at a time in and out of the microscope. Now, the microscopes also come with magnetically levitated pumps that constantly maintain high vacuum, and that reduces the frequency of cryocycling. So the recommendation is every 2 to 4 months. We see users doing it more frequently and others doing it less. Now, this together enables some unique functionalities that can be exploited in MultiGrid, such as constantly exchanging partial sets of grids while maintaining the same MultiGrid session. So you can do that for screening and removing only the bad samples and slowly filling up the storage with only the good samples that can then be run through a multi-day, multi-sample data collection. Or you can share this microscope with somebody else and you can start filling up the microscope and have all your sessions all guided by the same interface. I'll show you that in the next slides. Also, I want to talk about the cryoARM cartridges. The cartridges is where the grid sits. We have 5 different cartridges, but I'll show you the most commonly used ones. The standard cartridge is this one right here. It looks like a long rectangular plate. It has a cavity that accommodates a naked grid, and a C-clip secures the naked grid on the cartridge. And the second most commonly used is the autogrid compatible cartridge. Those take clipped autogrids. So the cavity is slightly larger, and there's a sliding clamp that slides over the autogrid, and it secures the autogrid. Now, as you can tell, this does not allow rotation of the grids. So when you're extracting a sample from the stage and reinserting it on a future date, there is no rotation. So there's no need for any alignments, any readjustments that take into account rotation. Furthermore, the stage drift between reinsertions of the same sample, it's impressively quite minimal. It's around 2 microns in the X and Y. So this number becomes negligible when you're doing your low magnification work. So when you're doing atlasing and you're taking your square images, you do not need a realignment routine. So you can really streamline the initial steps in setting up a data collection. All right. So I'm going to guide you now through MultiGrid and setting up a single particle analysis experiment for multiple samples. Now, I'm assuming that whoever is listening right now probably has some experience with SerialEM, so I'm not going to talk about the very specifics about SerialEM, but I'm just going to talk about everything you need to set up your multi-grid data collection. Now, you will need SerialEM 4.2 stable and beyond, and I would recommend that you do the 4.3 beta because it's going to have some additional features that were developed post-introduction of multi-grid. Now, after you launch SerialEM, you go to the navigator and you click on the Montaging Grids tab, and then you're going to see multiple grid operations. Once you click this, there's going to be two windows that open up. On the left, you're going to see your multiple grid operations window, so that's the multi-grid interface. And then you're going to have a navigator window on the right. Now, if it's the first time you're launching a multi-grid session, oops, I forgot to say. So if you click on Open Right, you're going to have 3 extra menus. These are the options of what you can run per grid. So the grid maps will be your atlasing. Medium mag maps, that would be your square images. And final acquisition, that would be, of course, your data collection. Now, when you're running multi-grid for the first time, you want to run an inventory. This is very quick on the JEOL. When cartridges enter the microscope, they get labeled by a unique ID number, and then they get tracked through the microscope. So the JEOL knows whether they're in the stage, on the transfer shuttle, or the long-term storage. So when you click on Run Inventory, SerialEM just takes all that information and retrieves it. So then you have to click Get Names, and then it's going to fill up this menu with all the cartridge information. You're going to have the unique ID number here, and then the sample name, and those are taken from the JEOL. Now, for this presentation, I relabeled everything as sample 1 to 12, but this specific microscope had 12 samples in the autoloader. Okay, next you want to set up your current directory. So this is done through this tab right here, but you also would like to click Use Subdirectories. So the subdirectories, each one's going to belong to each separate grid. So all those will be nicely sorted automatically through SerialEM while you're running the multi-grid experiments. All right, so next you pick grids for mapping or atlasing. In this case, I picked these 3. So you just check the ones. If you want to reorder them, you can do that by activating the set order. And then you check the first tab, the acquire grid maps. Now there's a bunch of options. We like to use imaging states for the low max stuff. So we have an imaging state. An imaging state is a pre-saved preset really that contains optics and camera settings. We have one for grid mapping. So as long as this is active, you can go ahead and submit it. There's options to remove or insert apertures, and there's the option to auto contour the grid squares, but I like to pick squares manually. And then you just submit start run. So the microscope is going to move through those 3 samples and do your grid mapping, and then it's going to move all the files to its subdirectories, and each navigator now is going to have the grid map that you can just load by double-clicking on the first line. If you want to move and inspect all the different atlases, you can just click on the sample number and then click Open Nav, and that'll open the navigator file associated with that sample. Now I want to bring your attention to the refresh list. That's a unique feature for the cryoARM. Since you can remove partial sets of samples, once you start doing some work and there's files that get sorted into the directories, refresh list will run an inventory in the back, and it's going to look if any of the samples have been replaced with new samples. So if you had, for example, if you've done a screening session and some of the samples are bad and you remove them, and then you replace them with some new samples, refresh list is going to keep the active sessions for the samples that are already in the microscope and replace only the old ones with the new ones. Also, once you're going through the different routines or the different steps, there's going to be labels for the samples. Here, they've been labeled as GR, that stands for grid mapping. So just by looking at the menu, you know that now you have grid maps for these 3 samples here. All right. So at this step, you may choose to apply a shift to marker. So the shift to marker, as you probably know, that will correct any image shift offsets between the field of use of your grid map magnification and your next magnification, which would be your square mapping magnification in this case. And if you do a shift to marker, you can store the marker. If you have stored a marker in the past, you can just retrieve that, say, stored shift by clicking Applied State Shift. Now, in the context of multigrid, this is important because if I do stored shift on one sample, then every subsequent sample that's going to be loaded onto the stage will be applying that stage shift. So that will be correcting all the offsets. So we click OK here, and then you can pick squares. Now, there's automated ways to pick squares with auto contouring. I prefer to pick them manually. To pick them manually, I just activate add points, and then I add points to the center of the squares that I like, and I tend to pick more squares than needed because if I ever have to return back to that sample, the session will already exist in multigrid, and all I have to do is just add more areas for data collection onto my pre-collected square maps. Once I'm done, I click Stop Adding, and then will collapse all these items into a group. And then I label the group as an acquire, so that puts the acquire tag, and now we can run acquired items on these squares. But through the multigrid interface, we don't have to do that. We can simply just check acquire medium mag maps. And then we also pick an imaging state. So we have an imaging state for square images. So that will be a single image per square at 250x. And then we start the run. Now, there are routines in SerialEM to realign grids when there's been some atlases and you get a grid reinserted on a later date. But for all the low-max stuff, as I mentioned before, the offset between grid reinsertions is quite minimal. So we have disabled those and really we've streamlined this way the navigation between different samples and collecting single square images and really kind of screening and setting up all the preliminary data points that we need for long unattended data collection. All right. So start run. It's going to run through all those samples again and take single square maps. And now we have MM, that stands for medium mag map. And then all those maps are in the navigator files. And then again, you can just go through all the different navigator files and check the maps, the square maps, and select areas in the square maps that you want to collect data on. Now, to select areas for data collection, again, there's a lot of streamlined automated steps in SerialEM. I prefer to do it the way I first learned, and that's by doing a grid of points and using polygons. So I'll show you how to do that. That's quite easy. You click on Add Polygon here, and then you draw a line around the square, and Stop Adding will complete. The polygon will give it a label, and we'll put the polygon in the navigator file. You can see the label here. Next, to add the grid of points, you want to add points into the square, but you want to take into consideration what your multiple record pattern is going to be like. Is it going to be a 3x3, a 5x5? And you want to give SerialEM information about the periodicity and the angle between holes. So in this case, if I'm running a 5x5, I make sure the points are separated by 4 holes. So this would be a pattern for a 5x5. So then we have the periodicity here, and then we do 2 more on this direction so we can give it the angle. And then we click Stop Adding. Then we go back to montaging a grid, add grid of points, and I select the navigator number, which was 19, and OK. And then it fills up the rest of the polygon with the additional points. Now you only have to do that once per grid. For the remaining squares, since SerialEM already knows now the pattern or the grid, you just go to subsequent squares, draw a polygon around the squares, only put 1 point, and then press Add Grid of Points, and it will fill up the rest of the squares with the grid of points. So even though it's manual, I find it quite easy and quite quick, and I've kind of stuck in doing it this way. All right. So next, you want to set up load dose. I'm pretty sure that most SerialEM users are quite familiar with load dose. I'm not going to go through a lot of detail, but I just want to tell you that when you do activate load dose, this gives SerialEM control over optics and camera settings. And you got 5 presets that you can use during data collection. In our case, record, of course, is for the data collection, so that would be your micrograph optic and camera setting. Trial, we use that for beam centering. So it's very similar to record, but we have a more condensed beam. So if there's any beam drift during data collection, trial is going to be used to recenter the beam. Focusing is used for autofocusing, of course. And then we use view for template matching. So instead of using align to items, we use a view magnification to align to a whole by using a template. And then finally, search. So in search, we pick a magnification in the mag range that has a larger field of view. But since we've skipped the steps for realignment that jump into the low mag and realign to atlas, we prefer to stay in the high mag range and realign to square maps. So we've introduced a script that when any new grid gets reinserted, it's going to go to search and it's going to take a square montage over a square, and it's going to align that square montage over the single square image, calculate the offset, and then it will readjust all your coordinate points based on that offset. So that way we can compensate for that 2 micron offset between grid reinsertions. All right, so finally you want to adjust your beam. This all can be done by SerialEM, so correct astigmatism is right here under focus and tune. Also, you can run your coma-free alignment here as well. And finally, you can calibrate coma versus IS. So that would be the image shift. So it's going to run an image shift coma calibration, and there's going to be a correction of coma during data collection. Okay. Also, you want to make sure you're saving frames. So if you go to setup and click save frames here and dose fractionation mode, of course, you'll have your exposure time, your binning, and your frame time. Now, we do have a script that will turn all this on. So we have a script that will take an image, calculate the dose from that image, ask you for the desired total dose on the specimen and how many frames you want. And according to that, it's going to update the exposure time and the frame time. So you're going to get, in this case, 40 frames. Now, since I did mention a script, I want to mention that SerialEM scripting with this extensive library allows further customization and automation. And before MultiGrid, we used to run single particle data collection using a framework of scripts. We called it the Osaka framework. And it was a series of scripts that we used to follow top to bottom that had consolidated and automated a lot of steps. Now, MultiGrid can do a lot of this stuff now, and it's very intuitive, but some of our scripts are still very useful and have been grandfathered in. So, for example, the one I just mentioned, test shot, that will adjust your imaging, your exposure time and frame rate. All right, so then we just click Run Final Acquisition. And before we start the run, I want to talk a little bit about the data parameters. You do want to click Make Frame Directories under Grid Directories. That's where the data is going to go. So the data is going to be under each sample folder. And then you want to activate Map Whole Vectors. Now, those are the vectors that are going to be used for your multiple record, and they're going to differ from sample to sample. So let me talk about this because this is a very clever feature that David introduced. So if we click to Set Final Data Parameters, of course, you have the whole menu of what you can do during acquired items. And the purposes of MultiGrid, we want to run acquire multiple records. And even though you have the option of setting all sorts of different conditions and actions, we have a script from the Osaka framework that we run instead that contains everything the microscope needs to know, or SerialEM needs to know about the microscope and doing the data collection. So that includes, template alignment, autofocusing, a bunch of checks to the microscope. And after it does that for every item, it'll run your multiple record. Now, if this menu is too daunting, of course, you can hide all the unused tasks and unselected options and clean this menu. So this way you can quickly check to make sure that everything you want is here. So we have our multiple records set up. We have our map whole vectors active. It's going to close the column valve at the end. And we're running the script before the primary action for every sample. You can set up your multiple record at any point during this workflow, but it gives you the option to set it up here as well. If I click on the setup, it opens up your multi-record dialog. Now, that includes how many images you want to take within the hole. So in this case, I took those images from a microscope that has fringe-free illumination. So we pick 4 images per hole. And then your multiple record. So you get a 3 by 3. You can extend that into the 5 by 5 because that's what I did for the grid of points. And then to get the vector information, you can extract those from a single square image by clicking map whole vectors. Now, this will also be active during SerialEM multigrid. So this will be done automatically during multigrid. Now, in this case, it's grayed out because we have ignored an important step. For SerialEM to be able to map the whole vectors, it needs information on the holes, really, the whole pattern, so periodicity and angle. And for it to know that information, you have to run the hole finder once per grid. Now, we have introduced this into the framework, so it does that automatically during the square taking step. So all that information is already known. But I just want to show you how to do it manually in case you have to do it. If you go to Navigator, so load a single square image, go to Navigator, Montaging and Grids, go to Find Holes in Regular Grid. That's going to open up this window. And you click on, you may want to adjust these values to help SerialEM identify the holes. And then you click Find Holes. And as long as it finds the holes, that's all you want. You just click OK and then exit that menu. So now in the background, SerialEM has that information. So the next time you click Map Whole Vectors, it's going to overlay the vectors along with the conditions for your multiple record. So as we have a 3 by 3, we see a 3 by 3 in here. If we extend that to a 5 by 5, this pattern is going to spread. And the center hole, you can see your intra-hole pattern, which is a 4 images within each hole. Now, those vectors are calculated in a low mag image, and they don't always translate accurately to our high mag image, which is at 50,000x will be the data collection for this microscope. Now, for that, David introduced a very nice feature. So the step-to adjust IS. So to run this, you have to go to your record magnification and align to an edge of a hole. So let's say the bottom of a hole. And you run the step to adjust IS. This is going to use the vectors, and it's going to, by image shift, travel to 4 holes. And for every hole it's going to stop, it's going to take an image. And then the user is going to have to drag the image to center the image relative to the first image. So anytime you drag the image, that's going to be imposing an image shift correction. And you're going to run that through 4 holes, and then it's going to finish the routine. Now it will have stored an adjustment factor. And really, you don't have to do this for every experiment. You do that once, and it seems to sustain quite well. In this case, those that had already been done, and it's been, that's why you see Apply Stored Adjustment is active. So if you go to Apply Stored Adjustment and you click on this, you're going to see the vectors, they spread a little bit. So because this is now representative of what's going on at 50,000, and it actually works quite well. All right, so in the context of multigrid, this is important because as long as SerialEM has the vector information for every sample that comes in, it's going to run the map whole vectors on a square image, and it's going to apply the adjustment factor. And it seems to translate very well and to be quite robust. And we get very good targeting, even with our systems that have fringe-free illumination. And we're doing multiple acquisitions within each hole. All right, so out of the data parameters, back to the interface. As long as this is checked, you just start the run. And your multi-sample data collection begins. So what goes on is that SerialEM will automatically progress through all your selected samples. So it's going to complete a data collection and move on to the next one. Anything that has been completed will come up with a tag that says AQ. As I mentioned, your images vectors will be automatically recalculated and readjusted for each grid. And each grid, we've introduced a script that would realign each grid to its square maps using a high mag map alignment script by using either square montages or corner montages, and that will be done to correct the reinsertion offsets. And the reason we do that is because we find that optic stability when we maintain the high mag range allows for multi-day and attended operation without coma stick drift. We have reports in the field of users collecting data 7 to 10 days without the need to correct coma or stick. And then finally, with the refresh list, you can pause the data collection, take out expired samples, put new ones in, refresh list. They will populate their section in the inventory. You can go back to those and do all the Lomax stuff, and then the mapping and the grid mapping, and then add those to the queue and just continue your multi-grid data collection. So to conclude with some summary and insights from running this workflow on the cryoARM, multi-grid is simplifying data collection setup, so it's a lot easier than it used to be. It allows robust and automated data collection of multiple samples. And the customization of SerialEM really allows users to design the best workflows for their system. So in our case, for example, the accurate stage and grid positioning on the cryoARMs that allows seamless movement between grids via the multi-grid interface with no need for Lomac alignments. So we've disabled the Lomac alignments and we're just quickly doing all the setting up steps in the Lomac. And also we have introduced scripts that will correct the 2-micron stage drift between the reinsertions by aligning montages to square maps. And finally, the refresh list, that's again a unique feature for the cryoARM, but that allows our users to cycle fresh grids into their queue without starting a new session. So they can run one session really for until it's time to bake the microscope and remove all the samples. Okay, some acknowledgments. Of course, I want a huge thanks to David Mastronardi for all the amazing work he's done at SerialEM and MultiGrid. MultiGrid has been just a dramatic improvement in the productivity of our customers. I want to thank the folks at Generate Biomedicines. When David first introduced MultiGrid, we started testing it right away at the cryoARMs over there, and we're able to give all that feedback back to David and resolve some preliminary bugs and also quickly add some new features that really customize this workflow for the cryoARMs. And also, I want to thank Angelica at Scripps. We've recently set up MultiGrid at Scripps, and all the images I showed you was from the cryoARM over there.